That's how it works. Right? The longer you're in class, the smarter you get, the harder the homework is, right? Good. It's going to be good for you. Okay, let's pass the homework to the very end. Okay, so right here in the middle, you guys get to choose where we're going to pass it to the end, and then to the forward. Okay? So I'll just grab it from you to right here on these ends. Is that okay? We'll figure it out here in a second. Okay? Don't worry about it. Well, let's see. We'll figure it out. Alright, you guys got all your homework? Turn it over here. Coming in over. I got it. Thank you.
You want to call you Mr. Potter or what?
You can call me Mr. Potter, you can call me Kobe, you can call me...
Kobe, sorry, I thought you were
So you know, there's a lot of Wyatts here, so... We got everybody's homework? Going once, going twice? You didn't pass it over. Oh my God. Evan's right here. Can we reach? Thank you. All right. So, first things first. You guys did the homework. Easy enough? Any questions? Do we need to talk about them at all? Okay. You guys know all about the different types of engineering now, yeah? Sure? Good enough? Not all of them, there's a lot. We didn't even talk about all of them, because there's millions and millions of them, right? But the ones we talked about, you guys feel pretty good about those? Alright. Today, before we talk about the great egg drop, we have a couple things that I should have talked about yesterday that I forgot about. So the first thing is the syllabus. Okay, I didn't put this on canvas yet, but I will. So this is what you need to know about the class. Okay. So first thing first is me. My name is Kobe Potter. You can call me Kobe. You can call me Mr. Potter. That's it. So you can call me Dude. I'll probably ignore you though. You can definitely try. I might beat you up though. Just kidding. The materials you need for this class, mostly were just provided for you by SVU Prep, right? So you have your paper, you have your pencils, your pens, whatever you need there. Should be good to go. What we are going to do is for the egg drop test, for a bottle rocket experiment we're going to do later on in the year, and maybe for some other experiments, I'm not sure, you will need to bring your own materials, your own supplies. Okay? So we'll talk about it a little more with the egg drop test, but whatever you guys want to use to make your egg drop test, you will have to provide that. Okay? You have to bring your own egg. So we'll talk about it here in a minute. We'll get it figured out. Okay? But you guys will have to bring your own stuff. All right? Any questions? Okay. The course topics for this class, this is engineering. So we're going to talk about engineering stuff, right? So we're going to talk about stress and strain, compression and tension, torque, bridge design, potential kinetic energy, Newton's laws of motion, bridges, skyscrapers, and other architecture, engineering design, voltage, resistance, current, and power, Ohm's law, Kirchhoff's law, AC versus DC, parallel and series circuit structures, and robotics. Any questions there?
Robotics.
Yeah. We have a couple of little robots that we'll put together, and we'll just talk about the, how circuits play a part in robotics, what robotic design means, the limitations of robotics, the benefits of robotics. Yeah. There won't be much programming or coding in here. We don't have access to computers for it, and I've only taken one programming class, so I'm not very good at it, so I can't help you very much. You're probably better campus, okay? Even me, I'm just a student, so we have to behave accordingly. So if there's anything that you're thinking about doing that you wouldn't do in front of your parents or in front of your teachers at school or anything like that, probably shouldn't do it, okay? This is just to make sure that we can keep coming back here, we can keep using this beautiful campus. So, miscellaneous, we're going to try and turn off all electronic devices during class. You shouldn't need your phones or anything like that unless we're doing math. So if you can pull them out for like a calculator or something like that. Also, food and drinks, we shouldn't have any of that in here just because it makes a mess. Except for water bottles with a closed lid, right? So just make sure you have your lid closed and we'll try not to spill any liquids or anything in class. The syllabus is subject to change if necessary, so things might look different as we go along. If we're going really fast, maybe we'll go fast or something. If we're going really slow, maybe we'll slow down and take some time. This is what our schedule should look like, okay? So this is all wrong, right? Today's Tuesday, today's Tuesday on Wednesday. So yesterday we should have done just the pretest and then introduction to the syllabus. You guys all took the pretest again, right? In study hall?
I couldn't get onto campus because my computer was broken, so I think I'd be able to.
Okay.
I think I did the free test.
Just that not sure about site isn't available.
Okay. So you'll have to talk to either Jody or somebody else in the study hall
I'll try it again.
to figure out the campus, okay? I'll go back in and I'll open up that assignment again, because I think I closed it. So I'll go back and make sure it's open, so whenever you get in there, you can take it, okay? It's the same one we took in class, that paper one. I didn't know that they needed an online copy instead of just a paper copy. So that's the only reason we did that. So sorry to make you guys take it twice, but so that was the pretest, and I just went over the syllabus. Last time we talked about the different types of engineering, and so now we'll do a little bit of an introduction to the egg drop experiment. Is that all right, everybody?
Yeah.
All right. Okay, so before we get too much into reading the egg drop experiment, let me close this so you're not distracted. We need to talk about a couple things so that we know what we're trying to do. You guys know what speed is?
Yes.
Yeah?
Yes.
Think you know? What is speed? Yeah.
How fast something is.
How fast something's going. That's a good one. What else?
The rate at which fast something is going.
The rate at which something's going. Okay, good. Anybody else? Does everybody know the units of speed? That's kind of a tricky one. Yeah? Yeah, sure. Whatever. So SI units is that's a classification of units, right? So there's SI, which means standard something, I don't remember. And those are like meters, kilometers, seconds, kilograms. That's SI units. But do you know the units for speed? Miles per hour. So that's what we normally use, right, is we call it MPH, right? But that really just means miles per hour. Okay? So if we did this in SI units, which is what you said, this would be meters per second, right? Which we usually just go M over S. Okay? But what this really means, miles is a unit, is a measurement. Hours is a measurement. Meters is a measurement. So we can convert all of these. What we really need to know is that this is distance over time, right? Because an hour is a measurement of time, a second is a measurement of time, a mile is a measurement of distance, right? How far something is, and a meter is a measurement of how far something is. So what speed really is the distance of measurement. It's a measurement of distance over time. Okay. Do we know what velocity is?
Velocity is the force that you gain as you're speeding or you're falling, and it's like the force that you get, and then it gives you momentum, which helps you keep going.
Okay, good. So there's a lot of words there that we're going to kind of break down as we go through this, but those are some good ones.
Well, I'm mainly knowing this because, like, funny story, I was talking to my dad about how great it would be if it was raining tacos. And he said, well, if you
It might just explode in your hand, right? But here you'd probably be okay. Tacos aren't too hard, so you'd probably be okay. What if it's maybe it would just crumble like chips, right? If I threw a chip at you really hard, it would just. So I think you'd be okay. I think you'd be okay.
So the
Yeah.
next terminal velocity, it's like the maximum speed something.
Good.
So velocity would be like the rate at which something in seconds.
Sure.
Rate
Good. Good. So that sounds a lot like speed, right? So velocity and speed, they're pretty close to each other. What's the difference between velocity and speed? Does anybody know?
Speed is the distance and velocity is time.
Okay, so that's close, but we know speed is distance over time. Oh, sorry. So that's close. That's a good idea.
Would it be like speed is the amount of, like, how fast you're going per, like, let's say, miles, second, meters, or like a distance, right?
Sure.
And then velocity is how fast something is going.
Sure. So close. Close. Anybody else? Okay, so this one's it's a little tricky, right? Because most of our lives, normally when people talk about speed and velocity, they're the same thing. But when you're an engineer, they mean slightly different things. Okay, the main difference is that velocity has direction. Okay? So velocity has to have some kind of a direction. So I could say I'm going 25 miles per hour in my car. And that's a speed. But if I say velocity, I have a velocity 25 miles per hour south, or north, or to the left, or to the right. Velocity has to have a direction. Okay? And that's because when we draw velocity, we draw it as an arrow like this. Okay? Speed is just a line when we draw it, but velocity has an arrow, which means there's a direction, because it could either be going this way, or it could be going this way. Okay? Does that make sense? Any questions about that? Yeah. Yeah. Okay. Good. Sure. So inertia is actually a property of matter. So anything with matter has inertia. Inertia tries to keep something from moving, or it tries to keep something moving in the same direction. And we'll talk about that more when we get into Newton's laws. But we're just going over this right now. So that's a really good question. And yes, they have a lot to do with that. So the units of velocity are the same as speed, okay? So it's still distance over time. But it has to have, so I'm going to say with direction. Okay? Now the next step here, does anybody know what acceleration is? Yeah.
It's going from one speed to a higher speed.
Good? Same thing? Okay?
Isn't acceleration just like speeding up?
Yeah. Okay, good. Speeding up.
Acceleration is an object moving forward at an accelerated rate.
Okay. Good. Sure, good. Yeah. So from 0 to 60. Did you have something?
Accelerate is seeing how fast you go from one speed up higher to a speed, and that's how fast you accelerate in that line.
Good. Perfect. Yep, those are all absolutely correct. So acceleration is how quickly we can change speeds. So distance or speed is how quickly we can change distance, right? So we're changing distance over a change in time. Okay? Acceleration is a change in speed. So it's a change in speed over a change in time. Okay? So that would mean if this is the same as this, that means that this is really distance over time again, right? Yeah, everybody with me? Does that make sense? And so we can say that this is actually distance, over time squared. Okay? So when we measure distance, or when we measure acceleration, it's going to have a unit of, if you did meters, it would be meters per second squared. Okay? So that's the SI unit of acceleration. So, when we talk about this egg that we have that we're going to drop, okay? When it starts, we're going to drop it off the side of one of the buildings here at school. So you have your egg. When it starts, it's at this distance right here. And we'll call this distance, I don't know, maybe 20 feet. Okay? For our egg drop, that's what we're going to do, right? We're going to take an egg and we're going to drop it at some distance, right? When it starts, what's the speed of that egg? 0, right? It doesn't have any momentum or inertia because it's still sitting there, right? But then it accelerates. And so in that fraction of a second, when you let it go, it's going to get a little faster. It's going to get some speed at that time. And then it's going to start moving with that velocity pointing straight down, right? Because that's the direction of our speed. Okay? And then after a little bit of time, it's going to accelerate some more, right? Because of gravity. And so now that that speed is a little bigger, the direction is the same, but we have this speed, which is getting bigger to this speed. And what do you think is going to happen after even more time? Keeps accelerating, right? So that arrow, this vector, or this velocity, is just going to keep getting bigger and bigger, right? And that's what you talk about with terminal velocity. At some point, it's going so fast that it can't go any faster. That's as fast as it can go. Now, we won't get there in 20 feet, right? But it's going to get going pretty fast. And so our job here is we have to find a way to slow it down before this egg hits the ground so it doesn't break, right? Do you guys know what force is? Yeah.
Force is like what happens, like if you're falling and you're gaining velocity, and then when you hit the ground, that's force when it hits the ground.
Good.
Can I bring a drone and then use the drone?
We'll talk about that later when we talk about the egg drop, okay? So we'll talk about that later. But do you know anything, you know what force is?
How fast something's going when it hits the ground?
So that's speed.
No, how hard it hits.
How hard it hits, okay, that's different. And then how fast it's going, right? That's a different
Like,
thing.
I was saying once it stops, how
Okay.
hard it hits.
Okay,
on the
good.
ground. Is it the pressure between two?
Kind of. That's a good way to think of it.
It's all the external forces working on the end.
So, okay, so we can say that, but the question is, what is a force? So when you talk about external forces, what are those forces?
Like the air, gravity,
Sure.
maybe a parachute.
Maybe a parachute.
Isn't it like something active on the
Good. 100%. So, force is all of those things. You guys are right. There's an equation for force. I don't know if you guys know what it is, but it's the mass of an object, so how heavy it is, times the acceleration. Okay? And so force is what you guys said. It's how they interact with one another. So it's the pressure or the push of one object put onto another object. Okay? So we have gravity as a force pulling down on our egg, right? Gravity pulls everything down towards the middle of the earth. And that's the only force acting on our egg except for air, which doesn't really do a lot until you get going really, really fast. Until that egg hits the ground. And then there's a new force, right? The ground has a force pushing back on that egg. And so they're going to come and they're going to push down on each other really hard until their forces kind of cancel out. Okay? So we have, let's say we have our egg like this. the egg's going to have a force of gravity that pulls it down. So we'll call that G for gravity. And it's going to have a force pushing up on it, and we'll call that the floor. Okay? And so the force of the floor is going to push up on this egg, and the force of gravity is going to push down on it.
And then it's gonna break apart.
So it could break apart, right, if those forces are strong enough. So we want to try and make these forces as small as we can so that egg doesn't break, right? And we know that force comes from mass times the acceleration. Okay, we can't change the mass of the egg, okay, because it has to be an egg. Can we try and change the acceleration of that egg?
Yeah.
That's what we're trying to do right now with this egg drop experiment, right? So we need to find a way to make sure that when this egg hits the ground, the acceleration of the egg is small enough that our force isn't enough to break the egg. Does that make sense?
I have old mono rocket fuel canisters and I attach them to the egg and light the food.
So you guys all talk about what you want to do, how you want to do it. We'll talk about that later. Okay?
I mean, when with someone like you hit the ground right, it's like lots of rubber band around it, or hit the same force, but then like it just like goes backwards. And
Sure. So the idea is the rubber bands. So if you had your egg like this, right, and you had a bunch of rubber bands around it, the idea is that the rubber bands would hit and that they would squish, right? So your rubber bands would go from this to like this, right? They would squish. And so then your egg itself, it has slowed down, right? Your egg has less acceleration because the rubber bands took a lot of that. So that might work if it'll slow it down enough. You don't know until you try, right? You had a question over here?
Say I were to bring a bunch of slime and put it around, it's bouncy slime.
Sure.
Would I be able to do that?
You can do whatever you want. You can try whatever you want. But we have to, well, why would you use slime? Because it's bouncy, so it's going to slow that egg down. So maybe that works. Maybe it's not going to slow it down, and it's going to bounce it back and put even more force on it. So you just have to try and think about why are you going to do what you're going to do.
So does it have to be a chicken egg? Say I wanted to do a duck egg.
It's going to need to be a chicken egg, so everybody's is the same, right? We just need to make sure it's all the same so everybody's fair.
Are you sure I can use a rocket fuel?
So I said we'll need to talk about it. You probably won't be able to use rocket fuel. That seems a little extreme for an egg. Okay, but does this make sense to everybody? We're trying to find a way to slow down our egg so that our force is as small as possible. Okay? All right. Okay, so let's take a look now at this egg drop experiment and what we need to do. Okay? So this says,
We need to save a whole bunch of African
that's
people.
right. There's a terrible drought in East Africa. The United Nations is working to get vitally needed medications into refugee camps. It takes too long, and it's too dangerous to bring the medications in by truck. It is also considered too dangerous to land the plane, so it has been decided that the medications will be airdropped. You guys are now part of a team of engineers who have been asked to design a container that will protect the medication as it falls. Yeah?
Why don't we just use a helicopter and hover a few inches over the ground?
It says it's too dangerous to land. If you get close to the ground, something bad's gonna happen to you.
She said just to hover the.
Yeah, if you get even that close, it's still too bad.
And there's one egg for every 6 people.
Yeah, that's the plan. Okay. You will model this problem using a raw chicken egg. It doesn't say chicken, but it needs to be chicken so everybody has the same ones, okay? There are some important volume and mass restrictions for the container and height requirements for the drop. It will be important to work well with your team in analyzing the problem, designing and building and testing your container, and analyzing your results. So you will be assigned to a team. Your design must not include any changes to the egg in any way. No tape, no nail polish, no hollow eggs, no hard-boiled eggs. You will write a lab report and produce a final product to demonstrate, describe your work.
Can we take stuff to the egg?
Nope, says you can't. No tape on the egg. can use tape, it just can't be on the egg itself. Try and like hold the egg together. Okay?
What day will that drop?
Be soon, let's check this. Tomorrow. Yep. Yeah.
I was gonna ask if you could maybe find a way to, could you use a chicken? That's all I'm trying to say.
A whole chicken?
A real
Whole real chicken?
Yes, like find a way to, put the egg on the chicken and see if the egg is gonna drop the chicken.
So that's an idea, but this is engineering, right? So let's try and engineer something, not use a chicken. Alright? And the chicken won't fly in the container, you'll be in trouble then. So what do you use an egg? You can put your egg in eventually. Alright. So, alright. Can I get everybody's attention, please? Alright, we need groups of 6. Can you guys make your own groups of 6?
Yes.
Alright, you guys have 2 minutes to find a group of 6 and sit by your group, okay?
What if we use like straws?
What do we have here? You have group 5? So this is, you guys now have 1, 2, 3. You guys now have 6. You guys okay? You guys get these 4 people, okay? Let's make sure we can make groups of 6. You 2 have groups. That people's group here, why don't you 2 join these guys over here so you guys can make 6, okay? What do you do? Okay, you guys say here, we'll figure out, but we might make a group of 7. You guys got your group of 6? All good? 5? Okay. We'll do that and then we'll make a group of 7. You guys have a seat for the 3, make a group of 7. Give me 1 second. Just making sure everybody's got groups. You guys good? Is this a group of 4? Okay with you? Alright, you guys got your groups put together? Everybody happy with their groups? Alright, so, like it says, there are some more requirements for this, okay? Other than what we've just said, there are some volume and mass requirements, okay? So, you're going to want to write these down so you don't forget. The volume has to fit inside of a shoebox. Okay? Is that alright? It has to fit inside of a shoebox. And it cannot be more than 10 pounds. Alright, write those down so you don't forget. It has the volume, has to fit inside of a shoebox, and the mass cannot be any more than 10 pounds. Okay? There can be no live animals. Okay? No chickens. There also can be no robotics, so no drones. Okay? No drones, no live animals. Has to fit inside of the shoebox. That's not what I said. Is that part of robots or live animals? No. Yep. Those are the requirements, okay? 10 pounds, shoebox, no live animals, no robots. No, to put on the ground? You're gonna hold it. No, it has to land on the ground. It has to land on concrete. It'll land on concrete or grass. Can't put anything else underneath. Yeah. So what we'll do next class, hey, everybody real quick. What we'll do next class is we'll take half of the class to build it together. And then the last half we'll test them. We'll go drop them off the roof. Okay? We're going to do it tomorrow. So you have today to plan. You have to gather your stuff tonight. And you have to bring it tomorrow and build it here in class for the first half. So you have about 30 minutes to build it. And then the last 30 minutes we're going to go drop them. Okay?
That doesn't work.
Make sure you know Make sure you know who's winning the game. Make sure you know that. Let's go over here.